Right, so part C, as it is saying, it says that y is equal to 2x over the square root of 1 plus x squared. Now this question, I am going to use implicit differentiation to do this. Anytime I see square root, implicit come to my mind. Anytime I see square root, honestly. If you don't know implicit differentiation, click the link in the description and watch that video on implicit differentiation. So to do implicit differentiation, first thing we're going to do is square both sides. So we're going to get y squared is equal to, when I square both sides, I'm getting the numerator when I square it is 4x squared over the denominator is 1 plus x squared. Now doing implicit differentiation is easy for me to differentiate this now. Doing implicit, I can differentiate this now to carry down the power to get 2y times dy by dx. That's implicit differentiation. So that becomes 2y dy by dx is equal to, start with the bottom, which is 1 plus x squared, times the differential of the top. The differential of the top is, that looks like 8x minus the top, which is minus 4x squared, times the differential of the bottom. The differential of the bottom is 2x over the bottom square, and the bottom square is 1 plus x squared. Nice, this is 1 plus x squared. Okay, 1 plus x squared all square. Now I'm going to expand out the numerator. Expanding out the numerator, I get 1 times 8x is 8x plus 8x times x squared is 8x cubed. And then I have 4x squared times 2x, that's also 8x cubed. So notice that the 8x cubed, them cancel each other. All right, and now I'm just dividing by 1 plus x squared all square. So the differentiation part done already. All we're doing is just testing our algebraic skills now. Differentiating part done is just algebraic skills. So this implies now we have 2y dy by dx, 2y dy by dx. We have 2 dy by dx is equal to, we have that this is equal to 8x plus 8x cubed minus 8x cubed. So that is just 8x over 1 plus x squared all square. 1 plus x squared all square. All right, nice. Now, next thing we're going to do is divide through by 2. Dividing through by the 2y, we're going to get dy by dx. So we're going to get dy by dx is equal to, when we divide through by 2, this becomes 4x over, we divide through by 2y now, you know. So this becomes 1 plus x squared square, 1 plus x squared all square times y. All right. But remember the question wanted x dy by dx, don't it? It wants x dy by dx. So to get x dy by dx, we need to multiply both sides by x. So let's multiply both sides by x. So what that is giving us then is x dy by dx is going to be equal to, multiplying both sides by x, we're getting 4x squared over 1 plus x squared, 4x squared over 1 plus x squared all square times y. But now look at this now. Look at this. Remember 4x squared. I can break up 4x squared as 4x squared can be broken up as 2x times 2x, don't times 2x squared, don't it? I can break up the numerator as 2x times 2x. Then in the denominator, I can break up 1 plus x squared as the square root. I can break up 1 plus x squared as the square root of 1 plus x. This can be written as the square root of 1 plus x times the square root of 1 plus x times 1 plus x squared. This is the square root of 1 plus x times the square root of 1 plus x times 1 plus x squared. And it is still being multiplied by y. I can break up the denominator like that. All right, nice. Okay, good. Now look at this now. What is 2x over, what is 2x over the square root of 1 plus x? But look at this, we don't even have to write the numerator as 2x squared. We don't even have to write it like that. We can write the numerator as 2x times 2x times x. Yeah, man, times x. Because guess what? Guess what? Look at that now, 2x. As we can see, this part right here, wait, 4x squared. Yeah, 4x squared is 2x times x. My apologies. 4x squared is 2x times 2x. Now, what am I saying now? I am saying that this 2x over the square root of 1 plus x, this part is y. This is y, and this 2x, that is y, and this 2x over the square root of 1 plus x is also y. This part is also y. Nice. And so what we're getting is that this answer is working out to be y times y is y squared. So I'm getting y squared over 1 plus x squared times y. 1 plus x squared times y. So that is x dy by dx. So to finish it off, we have that x dy by dx, x dy by dx, x dy by dx is equal to, we have y squared over 1 plus x squared times y. We can then divide. We can see that the y squared, this y squared, you can break up y squared as y times y in the numerator. And if you break it up as y times y, this y cancels this y. And so finally we can conclude that x dy by dx, x dy by dx is equal to y over 1 plus x squared. So again, just use implicit differentiation and it works out so easy. I highly recommend learning implicit differentiation. I know a lot of teachers do not teach implicit differentiation at the Unit 1 level. So I highly recommend you learn it, and you should. If you don't know implicit, check out the link in the description to watch implicit differentiation. Now let's look at part 2. Part 2 of the question, it says, show that d2y by dx squared plus 3y over 1 plus x squared all squared is equal to 0. So to show part 2, right? Oh, make sure you put that you show it now. So proven. All right, so it's proven. All right. Okay, so for part 2, it's a second derivative question. What I ideally, anytime I prove something, I like to start with that. So I just proved that x dy by dx, x dy by dx is equal to y over 1 plus x squared. All right. X dy by dx is y over 1 plus x squared. So I'm going to start with that. X dy by dx is y over 1 plus x squared. So if I divide both sides by x, if I were to divide both sides by x, in reality, dy by dx is really equal to y over 1 plus x. Y dy by dx is y over 1 plus x squared times x. All right, that's dy by dx. So now from this, I can go ahead and find the second derivative. The second derivative, I'm going to use quotient rule. So d2y by dx squared is equal to, start with the bottom. So the bottom is 1 plus x squared times x. In reality, that is x plus x cubed. So it starts with the bottom times the differential of the top. When you differentiate y, you get dy by dx. And we already know what dy by dx is. It's in this line minus the top, which is y, times the differential of the bottom. When you differentiate the bottom, you are differentiating x plus x cubed. When you differentiate x, you get 1. When you differentiate x cubed, you get 3x squared. And this is all over the bottom square. I don't like this line. Let me fix it better. All over the bottom square. When I'm squaring 1 plus x squared, what I'm going to get is 1 plus x squared square. So I get 1 plus x squared square times x squared. That's what I get when I square the denominator. So this is d2y by dx squared. So going around here, what I get is d2y by dx squared, d2y by dx squared is equal to, now that I have this, x plus x cubed dy by dx minus y times 1 plus 3x squared over this. I can go ahead now and simplify this. Let's go ahead and simplify this. I notice that this part, I can separate them as two separate fractions. Yes, I'm going to separate it as two separate fractions. I'm going to write it as x plus x cubed dy by dx. And instead of writing x plus x cubed, I'm going to write it as x into 1 plus x squared times dy by dx. And this is all being divided by all of this is being divided by 1 plus x squared over x squared. I don't need to separate them yet. Let's just continue writing it out. So x times 1 plus x squared minus, I'm going to expand in with the y now. Expanding the y, it's going to be minus y minus 3x squared y. So it's minus y minus 3x squared y minus 3x squared y over, this is over 1 plus x squared, 1 plus x squared, all squared times x squared. All right, now let's look at how we can simplify this now. We want to simplify this, and as I can see, remember we said that what is dy by dx? What is dy by dx? We're going to substitute for dy by dx right now, and everything else will work out. Remember we just said that dy by dx, going around here, this is dy by dx, y over 1 plus x squared times x. So I'm going to plug in that in here for dy by dx. So I'm going to make a big substitution. So pay close attention. So it's x times 1 plus x squared. And we had said that dy by dx is equal to, again, let's go back, look at it. It's y over 1 plus x squared times x. So dy by dx is y over 1 plus x squared, 1 plus x squared times x. That's dy by dx minus y minus 3x squared y over 1 plus x squared times x squared over 1 plus x squared all squared times x squared. Alright? Now what you get now is this 1 plus x squared cancels the 1 plus x squared. This x cancels the x here. Ah, nice. So all of this is just working out now to just be, this in the numerator works out to just be y minus y that gone. So it's just working out to be y minus y minus 3x squared y minus 3x squared y over 1 plus x squared all squared times x squared. Right now it just gets so basic, it's so boring now. Alright, so now it gets so basic that all we're getting now is d2y by dx squared is just equal to d2y by dx squared is equal to y minus y cancel, so you get minus 3x squared y minus 3x squared y over 1 plus x squared 1 plus x squared all square times x squared. Now as you realize now, this x squared cancels this x squared in the numerator, and so what are we left back with? What we're left back with is minus 3y over 1 plus x squared all squared. So now that this is what we get, we can just bring it over to the other side to get this implies now, adding both of them to, adding this to the other side, we're going to get d2y by dx squared plus 3y over 1 plus x squared all square. This is equal to 0. This is shown. Nice and easy, soft. This is shown. Nice. Alright, so that is shown. Nice and easy, soft. Alright, so this takes care of question 5. And now we reach the penultimate question of the paper. Penultimate means second to last. So we reach the final question of the paper, which is question 6. Alright. Now question 6 says the diagram below shows a region bounded by the lines y equals 3 minus